Hi, this is Anna McCullum. Welcome to this session on top enhancements in Oracle Database Monitoring. Many of our customers use Enterprise Manager for monitoring their database estate. Over time, environments change, new requirements may come from their own stakeholders, and hence they look to Enterprise Manager to continue to meet these new monitoring requirements. In this session, we'll cover the most recent set of enhancements in the database monitoring area. We'll start with monitoring using database service names, followed by enhancements to PDB monitoring. Then we'll discuss new features to enable you to meet new password policy requirements, automate your monitoring setup when database role changes, and then introduce you to our new simplified and efficient model for monitoring across your fleet of databases. A database service is an alias used to connect to the database. Database services are used, for example, in scenarios where you want applications to connect to a preferred subset of rack nodes. You can create services for your rack databases, single instance databases, and pluggable databases or PDBs. When Enterprise Manager connects to the database, it uses, by default, the database SID to connect to the database for discovery, monitoring, and admin operations like creating tables. Here we see two connections to the database. The connection from the OMS to the database is used to support access to the database performance pages and for admin operations. The connection from the agent to the database is used for metric collections. Now with a feature called Preferred Connect Strings, EM can connect and monitor databases using your service names. A Preferred Connect String is a fully qualified connect string that can override Enterprise Manager's default connection configuration to the database with your preferred connection method. You can create a preferred connect string using the host, port, and service name and specify that to be used for database connections. To use your connect string for OMS to database connections, specify it as an OMS preferred connect string. To use your connect string for agent to database connections, specify it as an agent preferred connect string. As mentioned, you can specify preferred connect strings for single instance databases, rack databases, and PDBs. For rack, you should specify the connect string for each rack instance, where the host parameter of the connect string is the virtual IP of the rack node. There are two ways to set up preferred connect strings. One is by using EMCLI add target or modify target verb. The second is by using the UI, either the discovery UI or monitoring configuration UI. When using EMCLI, use a properties parameter with the property name of preferred connect string for the OMS preferred connect string or property name of agent preferred connect string for the agent preferred connect string. The connect string value for that property is a fully qualified connect string I mentioned earlier. To specify the connect strings in the UI, you first need to set an OMS property, oracle.sysman.db.showAPCS, to the value of true and bounce the OMS. Once that is done, you'll be able to specify the connect strings in the UI. Here is an example of the target's monitoring configuration page, where you enter both the OMS preferred connect string and agent preferred connect string. As mentioned, for rack databases, remember to specify these connect strings for each rack instance. Then log out and log back into the EM console to update the OMS to database cache connection with the connection information you specified in the OMS preferred connect string. When monitoring PDBs that are part of a rack database, currently we require that all PDBs should be open across all rack instances. This is because in a rack environment, the agent that is currently designated as the master agent will connect to its associated rack instance. And if the PDB is not open on that rack instance that currently has the master agent, that will impact monitoring of the PDB. Customers, however, have indicated that they have configurations where PDBs are not open across all rack instances. Instead, the PDB is running and open only on one rack instance or a subset of rack instances. This configuration is now supported with the use of services and preferred connect strings. First, create a service for your PDB. Then create a PDB preferred connect string that contains the scan listener hostname and your service for the PDB. Then, similar to what we discussed earlier, in the monitoring configuration of the PDB, specify your PDB preferred connect string for both agent preferred connect string and OMS preferred connect string properties. Once specified, the agent will connect via the scan listener to the open PDB on your preferred rack instance whenever it performs metric collections. Refer to the EM documentation for more details on how to set it up. With the use of PDBs gaining more traction, we've added a rich set of metrics to help you monitor PDB resource usage on a per instance basis. These metrics include CPU utilization, buffer cache usage, I/O per second, average number of running sessions, PGA usage, SGA usage, and other metrics that enable you to more closely track PDB performance and resource consumption on a per instance basis. You can monitor these metrics from the All Metrics page and also set thresholds to get alerts. These metrics are also documented under the PDB resource usage metrics in the Oracle Database Metric Reference Guide. Whether or not DBAs choose to open the PDB on all or a subset of instances of a rack, they may want to get alerted if the PDB is not open on the desired set of rack instances. Or perhaps the PDB is open, but is open in restricted mode, and they may want to get alerted for this as well. The new PDB mode metric group supports these use cases. This metric tracks the mode of all PDBs across all rack instances. The mode metric indicates the current mode of the PDB, which can be read-write, read-write restricted, read-only restricted, mounted, which is the mode when the PDB is closed. This table shows the various alert conditions that you can monitor on PDBs running on each rack instance. If you want to get an alert if the PDB is closed on a specific rack instance, set the threshold of the mode metric to mounted. If you want to get an alert if the PDB has been open in any restricted mode, that is, read-write restricted or read-only restricted, set the threshold for any restricted metric to yes. If you want to get an alert if the PDB is open in read-only restricted mode, set the threshold for read-only restricted metric to yes. You may have scenarios where you need to monitor application metrics for a PDB. The solution is to create a metric extension for the PDB using a PDB local user. That is, a PDB user that has access to the application tables in the PDB. When creating a metric extension, by default, it will use the monitoring credentials for the target. For PDB specifically, PDB targets are monitored using the CDB common user, for example, DBAs and MP. For metric extensions, If you want to use credentials other than the default monitoring credentials, you will have to create a new monitoring credential set for the target of the metric extension. For the PDB use case specifically, you will have to first create a custom monitoring credential set for the PDB target type, set the PDB local user as the value for that credential set, then use it in the metric extension. Let's walk through this solution in more detail. To support this use case, we first enhance our credential sets to support creation of a monitoring credential set specific to the PDB target type only. You use the emcli create credential set command and specify the target type of Oracle_PDB and also the monitoring flag. Once created, you can go to the monitoring credential section in the console, choose your PDB, and specify the PDB local user as credential values for your new credential set. Once you've done that, when you create your metric extension for the PDB, you can choose a new PDB credential set that you've created. Being able to change database passwords across your fleet on a regular basis is critical and potentially time-consuming. To support this, in past releases, Enterprise Manager has introduced two types of jobs to change a database password in EM and in the database. There is the change the password for the database monitoring user job that changes the password for the database user that is used as monitoring credentials, for example, DBS and MP. The other job type, change a password for a database user, supports changing the password for any database user. These jobs have an option to auto-generate a new password. When chosen, the job will generate new values based on the general structure and format of the existing password. Suppose there is a change in the password policy. For example, there is a new requirement to increase the characters from 8 to 12 and add a special character. We've enhanced our password rotation jobs to support this scenario. Specifically, we've added a reference password feature. The reference password allows you to specify an example of a new password that meets a new password policy. For example, a password that is 12 characters long and contains special characters. You can think of the reference password as a template for generating new password values. When the job executes, it will use the reference password as a basis for generating new password values. You can run this job across your database fleet, thus providing you a scalable way to meet your new password security compliance requirements. When monitoring primary and standby databases, DBAs may want to put them in different groups because they have different metrics based on their role and different notification requirements as well. For example, databases in the primary group may require opening of help desk tickets for their incidents, while databases in the standby group have emails sent for their incidents. To enable the primary and standby database targets to be added to the appropriate groups in an automated way, you can define these groups as dynamic groups, which also include administration groups, and use a new target property called high availability role as their membership criteria. The high availability role is set to primary or standby based on the database's current role. When there is a role change due to switchover or failover, the value of this property is automatically updated accordingly. Let's give an example of how you can use this. Let's say you have a primary group G1 that contains your primary databases and its membership criteria is high availability role equals primary. Similarly, you have a group, standby group G2 for your standby databases where its membership criteria is high availability role is standby. Assume DB1 is a primary database and DB2 is a standby database. Let's see what happens when their database role changes. Suppose there is a switchover. DB1 now becomes a standby, and DB2 now becomes a primary. EM will automatically detect this role change and update their high availability role properties accordingly. This in turn will make DB2 automatically become a member of the primary group G1, and DB1 will automatically become a member of standby group G2. There are a couple of steps to enable the use of this new target property, and the MOS note referenced below has instructions on how to do so. When monitoring a fleet of databases that can run into the hundreds or possibly thousands, it requires an agent be deployed on every single database host. To monitor a new database, you'll need to first deploy the agent to each database host and then discover the database and its related targets, such as listeners, ASM, etc. When a new agent update is available, you'll also have to perform the task of upgrading all of the agents across your fleet. We're excited to introduce a simplified and efficient model for monitoring and managing your database fleet. With this new model, we leverage our next generation agent to remotely monitor and manage your entire fleet of databases. Gone are the days of deploying and managing individual agents for each database host. Instead, we can now achieve the same level of monitoring and management with a smaller set of core agents. Here's a high-level overview of the new process. First, you'll install and configure our next-generation agent, which also discovers its host. Next, using this agent, add the hosts of your database targets. For example, if you have a 2-node rack, you would add both nodes of the rack. Then discover the database and its related targets in the same way that you would do so if you were using a local agent. If you needed to discover additional database targets, simply repeat from step 2. That's a high-level overview. This will be discussed in more detail in the session Streamline Your Database Monitoring, Discover the Power of the Next Generation Agent. We know many of our customers rely on Enterprise Manager for monitoring their fleet of databases, and as new requirements come in, we continue to invest and enhance our features to meet these new requirements. In today's session, we've discussed our latest set of enhancements. These span from meeting specific use cases, such as monitoring databases using services, providing richer monitoring of your PDBs and rack environments, complying with new password policy changes, providing ways you can automate your monitoring setup across database role changes, to a new significant, more simplified and scalable way of monitoring and managing your entire fleet of Oracle databases with the new remote monitoring and management capabilities of our next-gen agents. For your reference, here are links to documentation and the MOS note that provides more details on the features we discussed today. Thanks for joining this session. Here are some additional resources on Enterprise Manager.